So, thanks for joining my talk today. I'm going to actually set a timer just in case I go overboard. Yeah, there we go. So I'm Christian. You've probably seen me from announcements and all that I've made in previous days. But I also have a talk for you. I guess you're pretty bored already by LLMs and what you can do with them and so on. But I wanted to just highlight a small example of something we've been doing at CERN in my group actually, which is making sense of your documentation using LLMs, right? I'll cover the fancy title in a moment. And this doesn't work, does it? No. Right, so the problem is the following. You come to CERN, you join our group, you get like a huge amount of documentation, and you're like, okay, how do I install EDH? EDH is one of the oldest things that we have at CERN. It's around the 30-year-old piece of software written in Java, starting from 1 up to 11 right now. And then it's like, okay, so I need to install it. There's a huge list of things that you need to do, and you just arrived, yesterday. So of course you're not going to be able to go through the documentation in a decent amount of time. So we decided, hey, why don't we do something about it? Let's build a chatbot. You ask it, but we have a few constraints. The first one is the fact that we don't want to send our stuff to OpenAI. I said yesterday, maybe some of you were on the tour, that everything we do is public. Yeah, kind of. I mean, some of the stuff is financial data, administrative data, HR things, the names of people and so on, right? So we can't afford to send it to the cloud. So what do? We keep it on site. We keep it all nice and enterprise, and we want to ingest our documentation so that we rapidly retrieve it using embeddings and all that, as you've probably learned if you've been to any of the other talks. The opportunity presented itself. We have a hackathon, which is yearly organized by the group, and we decided, okay, fine, let's ask for a beefy machine with GPUs and see what we can do out of it, right? We did some very thorough research, right? So we were like, okay, what do we use? First thing that you search on the internet, Hugging Face. Okay, fine. So there are some people that already trained the chat models for you. You can download them locally on your machine, and then you can play around with them. You can send some text, and hopefully after the GPU churns it, it spits out some more text for you, right? And we looked a bit at Alpaca Eval. I don't know if you know about it, but it's basically this site where they do like a fight against all the existing chat models and be like, okay, who's the best? This is a photo from October, I think, from last year. And we were like, okay, let's pick something which doesn't nuke our resources, because we probably can't run the 70 billion model. So we chose the 7 billion model, right? This one, which is highlighted at the bottom there, the Zephyr 7B, right? It's pretty popular, it's hosted by Hugging Face and all that, and then they have some documentation on how to use it, right? Simple enough. Then we have a REST API from Confluence. That REST API allows you to get the data, ingest it, then you tokenize the documents, because you can't put huge text sequences, right? So you cut it into slices of, 500 characters, 1,000 characters, depends on how much processing power you have and what's the context window of your model. You download all of those documents, you transform them into their embedding representation, and you put them into a DB, which is doing this kind of stuff, right? In our case, we're using Chroma, because it's nice and fast. We implemented the thing in Python, so it was really easy to interface with it. And then you save it to disk, or somewhere else, but we saved it to disk, in order to load it and look up the stuff very easily in the API in the future. So this is kind of how it looks like. I'm not going to bore you with the code too much, but the point is, like, you're splitting the text, right? Recursive character text splitter, then you split all the documents. You use one of the embedding models in order to populate your database, and you just call this very fancy Chroma from documents with your texts, your embeddings, and then it uses cosine similarity to find what you're searching for, right? And then how do you talk to it, right? So this is totally not stolen from the Chroma website. It's basically you send your query to the application and it generates an embedding that it searches in the vector space with, right? You've seen that in the presentation about the Pokemon and all that, right? So the embeddings are a list of numbers. That list of numbers is correlated somewhere in the space with all the other things which look similarly, and it's fed into the LLM context window, right? So it's used as a basis of knowledge for the chatbot to give you like an informed answer afterwards, right? And the input looks kind of like this, right? So this is what our system accepts. The only problem with the language models from Hugging Face is like read the documentation first, right? Because sometimes you have, sometimes it accepts, you know, assistant with like dashes or whatever. Sometimes it accepts it in this format, so you can say system, user, and assistant. Assistant meaning what the chatbot replies. If you implement history, then you're going to have some assistant answers before your actual assistant prompt there, right? So assuming this is the input to your chat model, your output is going to be basically filling the last gap over there because you have the prompt at the end. And in practice, what we do give it actually, is something like this. It's you're saying you're the assistant of the CERN business computing group. You should be answering in an intelligent way. I don't know. It seemed to work, right? So then we tell it, use the following pieces of context, so the part in black there, to answer the question at the end. If you don't know the answer, don't make stuff up, right? Chatbots tend to hallucinate. They tend to give random answers. And the context is basically a list of documents from 1 to k, where k is the number of search results that you get from your embedding, formatted like this. So you have the title, the URL, and the content. Why? Because people are asking questions and they don't know where to go in the documentation, right? So what we want to do is give them something to allow them to go to their documentation source, right? So every time it gives you something, it should cite that information back for you, so it doesn't give you crap, right? And this is kind of how it looks like. It's like, can you tell me how to install ADH based on the previous documentation example that I gave you back? And then it says, okay, look, based on the context provider, here are the steps to install ADH, right? And then it's like blah, 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 blah. It invents some information for you, but then it gives you the URL of the document, which is quite useful, right? And if I click on that document, don't try to access the link because it's internal CERN stuff. You're going to be hit by the SSO. It actually provides a valid URL. Sometimes it hallucinates with the URLs. They look very convincing, but actually they're not the real stuff. So yeah, that's a bit of a problem. But overall, I wanted to show you how it works, right? So we kind of built like a whole solution. If you have CERN SSO access, it's at bc-chatbot.web.cern.ch, right? So people that are on the CERN SSO can try it out freely. Yeah, let's... What's BC, right? So, I mean, people from outside of CERN, they have no idea, right? And maybe people that just came to CERN have no idea. So maybe let's ask it, right? Can you tell me what BC stands for? It has memory as well. Like you've probably seen that you can add memory to your models. It's nothing fancy. You're basically just storing the messages and then feeding them back into the model up to a certain window, right? So you're not passing all the history that you have because you don't have enough context window for that. Hey, so look, so BC is an acronym that stands for business computing. That's true. It's a group that resulted as a merger from AIS and TPR. I did not know that, but actually that's probably true. So, yeah. I don't know as much as my bot knows because I didn't ingest this documentation. It was the bot that did it. I put it in DuckDuckGo. Sorry for that. So let's see if the guide works. Oof, it does. There's question marks around there. TPR, what was it? Oh yeah. So look, the group's administrative information sections, AIS, and treasury, process, and reporting, TPR merged into the new group, business computing. You'll probably still encounter these old acronyms for the years to come. Yeah, well, look, we're in 2024, and you guys are seeing this. Yeah. Should I show you some code? Should I not show you some code? I don't know. Maybe, maybe not. Yeah, one interesting thing actually is we used something to serve our model. It's called reserve. I don't know if you've ever used it. I know you're more familiar with the JVM environment than with the Python environment, but it's quite cool. So if you search for reserve, it's scalable and programmable serving. So basically, it's made in order to serve your chat models by giving it exactly the amount of resources that you want to have. You can send jobs, right? So these jobs can actually, they can run somewhere, but you can also have infinite jobs like we have in our case, which are APIs, right? So we have this like most recent job, which is running for like 3 hours already. You can see some metrics about it, so it all comes for free for you guys, right? And it can also be configured so it runs it on a cluster of machines. So if you want to allocate a GPU but you don't know where that GPU is, it can do that for you automatically. So that's pretty cool. Yeah. What else? Yeah, the funny part is that it doesn't like names, so if you it tries to hide information. That's why in the prompt at some point we said that please you can use personal information of people, right? But then it starts really hallucinating, right? So if you say who is the head of the BC group, I don't know if it's going to give a right answer or not. I'm going to tell you if it's the right answer. Yeah, so the context doesn't mention the name of the head, which is probably false actually. Sometimes it does mention the name of the person, it's just it doesn't want to give it to you because it's trained to do it like that. So yeah. This is the tech stack more or less. So I'm using LangChain for some of the stuff. We won the hackathon, by the way, yay. We're using PyTorch for the models, for like loading them and all that. Hugging Face is used as an API interface. We're just downloading the models from there and using them using the transformers package from Python. And then we're storing the memory in Redis just so that it gets stored for a longer time for everybody that wants to use it. We did a nice small UI with Tailwind and all that. So yeah, that's kind of it. I'm a bit short, but if you have any questions, feel free to ask me. Thanks. Yeah.
I'm assuming your documentation is all in English. Have you tried that with other languages like French, for instance?
So I think the question was if we tried it with other languages as well. Yes, actually we have some documentation in French as well. I'm not sure if there's that much of it in here, but qui est le chef du groupe BC? I don't know if it talks French or not, but we're going to find out very soon. If not, it's going to probably explode. Ah, voila. So you see, it speaks French as well. So given the context, it says exactly the same thing, but what it said in English, it says in French. So that's not very useful. Comment está le EDH? That's probably also because of the context. So the context was in English, above there. So let's clear the thing and try it again. The prompts, so the context is in English, right? And whatever it finds is in English, but it does speak French. It doesn't understand that much French, right? Sometimes it answers in French, but if the prompt is in English, it should detect that your query is in French and then kind of do everything in French for you as well. Otherwise, it kind of falls apart. All right. Who else had questions? Yes.
2 questions.
Yeah.
Are you currently using it, and how much does the hardware cost to run this?
Okay, so first, if we're currently using it, The point is that when we requested the machine from IT, they gave it to us, but on a loan, let's say, right? So at some point they might pull the plug and like kill our GPU. This is virtualized GPUs, by the way, that we have in the data center at CERN. It's kind of a new stuff for them as well. But when you request it, you just create a machine of a certain type, and then it comes with the GPU for you with the drivers and everything. It's based on RHEL, and yeah, it comes with all the stuff. And two is, this machine is like a 20 gig GPU, so it has like a 20 gig A100 GPU, I think. So yeah, it's nice. Yeah, it's pretty good, but the problem is we don't have that many of them. So ideally we should give back the GPU when we're not using it anymore. I have a meeting next week or in 2 weeks actually, what I need to sell the chatbot to the product managers of the group. So then we'll see if they want to buy into the solution and what product of our group we're going to use it in. Probably not the onboarding necessarily, but something else that could be useful. Yeah. Yes?
Can you take a lot of parallel requests this way?
The question was if I can take a lot of parallel requests this way. No. So the problem is that you have one GPU, right? So the way that we thought about implementing it, if we actually built it as a solution, is you put a queue in front of it, right? So then you do one request at a time. Sometimes if you feed it too much, then the Ray process is not smart enough to figure out that the process died, and then because it uses too much GPU memory, right? And then it never releases that memory because it throws an exception. So then you need to like force kill it and restart the whole thing. But yeah, there are some interesting things there, but yeah. I mean, it was an experiment, it was a prototype, and I'm looking forward to see what we can do in the future. Yeah? Yeah, so actually what we wrote here, we wrote a very simple script, a dumper script. Do I still have time? There are still a couple of minutes, no? Yes, because there's only a talk in C afterwards, so yay. Yeah, so this is like the dumbest script you've ever seen, and I'm also doing unspeakable stuff like not trusting the certificate and saying, you know, like, fine. And you probably shouldn't see that token. But yeah, the point is that what we're doing is we download the stuff from Confluence, and we can do it on a schedule. So if you have your vector space populated, actually everything is chunked per Confluence space, right? So you have different spaces in Confluence, and each of them you can dump the whole space into the vector DB. And if something changes, we can do it nightly, right? So we just delete the vector store, which is quite small, by the way. It doesn't occupy a lot of space, even for thousands of documents that we have. You just repopulate it afterwards, and it works just fine. Yeah. All good? Okay, I'm pulling the plug. Thanks, everyone.